So, mechanical energy. The definition for gravitational potential energy. So, gravitational potential energy is the energy an object possesses due to its position relative to a reference point. We can use the equation EP is equal to mgh, where m is mass, g is gravitational acceleration, and h is the height above that reference point. We then get kinetic energy, the energy an object has as a result of the object's motion. We use the equation that Ek is equal to half the mass times velocity squared, and finally we get mechanical energy. Mechanical energy is the sum of gravitational potential and kinetic energy at a point. And we'll use the equation Em is equal to EP plus Ek. Now, here's an example. So we have a 5 kilogram object that is 10 meters above the ground. Firstly, we can find out its potential energy by using EP is equal to mgh. So 5 kilograms, 9.8 meters per second squared, and 10 meters above the ground, giving us a total potential energy of 490 joules. The object is standing still at the moment. That means that we have zero velocity, and so the total kinetic energy would be zero. Therefore, our total mechanical energy is just going to be 490 joules because we only have our potential energy and there is no kinetic energy. Now, if we let the object fall, we can do the same equations, but now let's try find out what the velocity would be at the end. So firstly, our potential energy. Now, potential energy still got our 5 kilograms, still got 9.8 meters per second, but it is at 0 meters above the ground. And so that means that it has no potential energy at the moment. Think about it, if we let this thing go, it's not going to go anywhere because it's on the ground already. We can then find out how much kinetic energy would be available to this object using our mechanical energy formula. So we line up with 490 joules. So let's find out how quickly it was moving at the bottom. We can use our kinetic energy equation. We substitute in what we have. We have 490 joules of kinetic energy available to it. We still have 5 kilograms and we don't have a velocity. And so then we can do the equation and we'll find out that we have 14 meters per second velocity at the end.